Paper 2 students. We are going to look at rate of change and slope today. So go ahead and update your table of contents. Then go to the page you're going to be writing. And what does rise over run mean is our essential question today. Make sure that you date this. Alright, today we're talking about rate of change. And rate of change is the change in y over the change in x. The slope is change in y coordinates over change in x coordinates, y2 minus y1 over x2 minus x1, and it is rise over run. This is something that is very important for you to memorize. If you look on your MCA formula sheet, this is not given to you on the formula sheet. So this is something that you need to have memorized all the way through till April. Okay, and then make sure you read through your study tips. Alright, example 1. We need to find the rate of change. So change in y over change in x. The Greek symbol for change is like that. Okay, how much do our y values change? Well, our y values in this case is the number of students. So our number of students would from approximately 57,000 up to approximately 60,000. So we're going to figure that out by subtracting those two. Alright, so grab out your calculators, subtract those two numbers, and I believe you get 3,413. Then our x values is our change in years. So it's going from 2004 to 2006. Subtract those, which is 2 years. So to find the average rate of change, you take the numerator divided by the denominator. And on average, it is the applications are going up by 1,706.5 students. Alright, take a second and read through this problem. We need to find the rate of change from 2001 to 2006. So we're going to use those 2 points and figure out what the rate of change is. And now we're just going to have to do some estimation here. So in 2001, it is at approximately, it looks a little bit more than 5, so let's just go 5.5. In 2006, I would say that's approximately 34. So our stores is our y's, so we subtract those, and that is our numerator. And that answer is 28.5. And then we put the denominator as how many years that has been, and that's over 5 years. So if we go ahead and divide that, it's changing on average 5.7 stores per year. And not a space. Okay, so let's talk a little bit more generically. How would we find the slope if we have a graph? Well, we've got 2 points on this graph, and what we can do is we can do slope by doing rise over run. So we first look at how much does it go up. Goes up 1. And how much does it go over? It went over 2. So our slope is 1/2. Now it is always important to check if the slope is positive or negative. If this is something that you get mixed up on, it would be a good idea to draw this. Here's an example of a positive slope. And here is an example of a negative slope. In this case, it is a positive 1/2. And how do we find slope if we are going through 2 points? That's going to require the equation y2 minus y1 over x2 minus x1. Now, if that is something that you're going to really struggle with, it is possible for you to plot these 2 points on a graph and then do rise over run, which you would do the same way that we just did that previous problem, but I'm going to show you how to do it using y2 minus y1 over x2 minus x1. Now, when we're talking about y2 and y1, we're referring to this point is xy1, this point is xy2. So our second y value is negative 2 minus our first y value is 4. Then we look at our second x value is 1 minus our first x value, which is negative 1. So our numerator will be negative 6, and our denominator, when you subtract a negative, you are really adding, so 1 plus 1 is 2. And then if we can reduce that, we should. This can be reduced to negative 3. So our slope is negative 3. So that's it for today, a really short lesson. So make sure that you remember to write your summaries and put your questions in the question column. And let me know if you have any questions from this lesson when I see you.